Remember when I told you that in order to calculate the magnitude of the gravitational force, we would need to know the value of G. Capital G is the gravitational constant. Now, pay attention to your capitals and lower cases because capital G is the gravitational constant. Lowercase g is acceleration due to gravity. So you can't just interchange them. They're very different numbers. Remember, the acceleration due to gravity was 9.8 meters or 9.81 meters per second squared near Earth, while the value of g is very different. The value of g, is, capital G, the gravitational constant, is 6.673 times 10 to the negative 11th. That's a very, very small number. And the unit for it is Newton times meter squared divided by kilogram squared. Okay, this is a number that you will be provided with whenever you have to do calculations. It's not one that you're going to have to memorize for this class, but the value of g is 6.673 times 10 to the negative 11th newton meter squared per kilogram squared. And that unit is a lot of times you see really crazy looking units for constants because the crazy looking units are the units you need in order to make the other units cancel out. So in an equation. So remember this equation is the force of gravity equals gravitational constant times m1 times m2. So that's kilogram squared over r squared. So that and r is measured in meters. So that's meter squared. So your meter squared is going to cancel out. Your kilogram squared is going to cancel out. And you're going to be left with newtons, which is what you want in a calculation where you're trying to determine the force. If you look at the problems below, you're going to see that the force between you're going to see a bunch of these gravitational force diagrams like we saw in the last slide. But we see that they have different masses or different forces or different distances between the two objects, and your job is to calculate the missing value. So in the first row, the force between the two spheres is negative 1F, where F is a particular value of force. You're going to determine the force in each of the other examples. And there are a couple where instead of determining the force, you're going to determine the distance between the objects or you're going to determine the mass. So pay attention to what variable is missing and use the correct units. So practice using this. You're not going to do real calculations right now. We'll do calculations next. So tomorrow you'll actually be doing calculations with gravitational force. But now you're going to try to understand conceptually how gravitational force changes with different masses and different distances, following the inverse square law.